Let's look at the following series and find if it's convergent or divergent. Let's analyze the series for n equals 1 to infinity of 3n plus 1 over 4 minus 2n to the power of 2n. So if we want to find if this series is convergent or divergent, what we can do is we can apply one of the general tests, like the ratio test or the root test. In this case, since the series corresponds to the following sequence, it makes more sense to look at the root test, since we are talking about a power, in this case a power of 2 to the n. So in this case, what we want to do is we want to use the root test. And in order to apply the root test, what we need to do is we need to find out the limit as n tends to infinity of the square root of the absolute value of an, the nth root of the absolute value of an. In other words, what we're looking in this case is the following thing. It's going to be the limit as n tends to infinity of 3n plus 1 over 4 minus 2n, everything to the 2n, and the nth root we can write down as 1 over n. Notice how I don't write down the absolute value bars in here, because we only have positive terms. In other words, since this expression has a square, we know that for sure everything is going to be positive. So now we can simplify this expression, and we can cancel the n's. Since we have a power of 2 to the n, that will cancel with the 1 over n. And then what we end up with is just the limit as n tends to infinity of 3n plus 1 over 4 minus 2n. And then I can throw in the absolute value bars, and I have the square. So again, notice how the n's cancel, so I end up just with the square. And this is a rational expression. In other words, the only thing that I need to do in order to find out the limit is look at the leading coefficients for this expression. Look how the leading coefficients are going to be 3 on top and negative 2 on the bottom. In other words, here what we end up with is just looking at the leading coefficients, and we can actually compute the limit in this case. So the limit is going to be just 3 over negative 2. That is looking at the leading coefficients of the expression inside of the square. And then we have the square over here. So this will end up being 9 over 4. That is the limit for that expression. And the root test tells me that if that limit is bigger than 1, then we have that the original series is going to be divergent. In other words, since rho is bigger than 1, we have that the original series is divergent by using the root test.